All right, so up next we've got two speakers at the same time. I know, it's exciting. It's going to be the switch back and forth. So we got Tristan and Aditi. They're going to talk about serverless, what was scaling, right? Yes, scaling serverless, which is obviously what we all want because we're all going to have all the customers. So please welcome Tristan and Aditi. Welcome. Thank you.
Hi, everyone. Sorry for that. So we are here today with Aditi to talk to you a bit about how we actually leverage serverless to create our own small POC and how we scale it to a production, to a scaled platform. So just to introduce ourselves.
Hi everyone, I'm Aditi and I work as a consultant and a full stack developer at Octo Technology.
So I'm a consultant as well and full stack as well. A few details about Octo Technology. We are actually a small consulting company, meaning that actually building product is not now our main activity. This impacted a bit the way we actually developed the software because we had a lot of developers working only small amount of time on their free time when they had the time, rather than having a full dedicated team that as it's usually happening. So let's talk a bit about the product. Today is about explaining to you how we came from just an idea to this product, Geopoly, which is basically a digital treasure hunts platform. So as you can see on the screen, basically you are on the map and you need to actually move to unlock challenge and be able to answer question. So the agenda for today is first how we created this MVP and then make it scale. And then what were the different challenges that we faced doing that. And at the end, a few key takeaways for you about what we learned about using serverless.
So the product that Tristan just talked about looks quite catchy and quite cool. But in fact, when we started working on it, we didn't really start like that. Well, in fact, in the beginning, it was just an idea. How about creating a geolocation game for geeks? And why for geeks? Well, because initially we had some troubles finding a new talent to recruit to our organization. So we wanted to use something for that we could use for our recruitment. We could make some noise about us and do some marketing about us, that how cool we are as an organization. So it's all started like that. And so we started to work on this idea as an MVP. And as you all know, an MVP is a minimal viable product, is all about think big, start small, deliver fast, fail fast, and get results quickly. So, and why did we choose serverless for our MVP? Well, we were definitely not doing some hype-driven development there. Well, we wanted to build something around geolocation, and we just wanted to make sure if we could build something meaningful out of it, if it was really possible. So with serverless, you don't need to worry about your infra and the bells and the whistles. So you can just build your code, ship it, and validate it. And that was perfect for us. So we started working on this little MVP using serverless. And so we created a static website hosted on S3. We had an API gateway which was integrated with Lambda. As a database, we used DynamoDB. Well, we wanted to be as flexible as possible, so we just went ahead with DynamoDB, and because it was easier. And boom, it worked. I mean, we were able to validate that we could do something really nice and meaningful around geolocation. And good part is we were able to validate this whole idea with serverless within $1 and within a week. So we chose to go ahead with this idea, and we also chose to go ahead with serverless for the MVP, because, well, this was a side project for us. I mean, we didn't really have any dedicated developers working on it. So not worrying about infrastructure and hardware, even before we should be worrying, was something really valuable for us. And we wanted to go to the market as soon as possible, and serverless ticked all these boxes. Now, when you choose to go with serverless, you also need to make a choice about how your Lambda functions should look like. Now, you can have one Lambda function which can do pretty much everything, kind of monolithic functions, or you can have you can have one Lambda function which is dedicated to just one feature. And we chose to go ahead with this second option, kind of serverless microservices, because, if imagine that you have some bug. So, and if you want to debug it, you can just go to the logs, find out the API endpoint, find out the associated Lambda function with it, which has not too much of the code, well, because it doesn't do too many things. You can easily fix it. It's easy to debug, it's easy to understand, and you can also have autonomous team members where each person can work on a functionality and doesn't need to be dependent on someone else. Now, when you decide to have one function per feature, definitely you end up having too many Lambda functions within your application. And you need to have some solution which helps you with packaging and deploying of everything. When we started working on this around 2 years ago, AWS didn't provide any solution for that. So we chose a framework which is called Serverless Framework, and which is quite nice because it helps you with the packaging and deploying, and also about your provisioning of your AWS infrastructure. So this is how Serverless Framework works. I mean, you just have one serverless YAML file, as you see here. You can define pretty much all the functions that belong to your application. So this is the single purpose Lambda of your application. There is an handler, which is, in our case, it was a Node.js function. There is the API endpoint that you want to associate with your Lambda, and all other nice options that you want to have with your Lambda function. So you just deploy this one serverless YAML file, and that's it. And other thing which is quite nice, I mean, on paper, it claims to help you become cloud agnostic. But well, this is something that we are going to see later if it's really possible or not. And this is the very primitive first version of our architecture for the MVP. So, so this is the static S3 website, and it calls the API gateway, a Lambda function associated with it, DynamoDB if it wants to read and write from the DB. For the front end, we chose to have Vue.js, and for the back end, we chose to have Node.js because it was quite nice, quite fast to move ahead, very simple. CloudFront, which helps you to make your website available globally. It helps you with the distribution and also provides SSL security on top of it. And for the backend, it's not just one Lambda, but in fact there are many more API gateways and Lambda for each of your REST endpoint. And on top of it, we had Serverless Framework, which under the hood creates a kind of cloud formation template to create all of your cloud resources.
So back to the story. We are now 3 weeks after this idea that we got. And we deployed this first version. So for us, the first version, it was really to see if as a game, it would actually, like, people would like to play it. So we created a first version. So it was an MVP. There was only a front end for the players. So that means that every configuration that you have as a creator of a game was actually on a JSON file on an S3 bucket. But because only developers were actually game creator, it was okay. So we ended up with these kind of screens. And now, after this, our goal was to validate. So we actually released the URL to everyone, and to everyone we knew, and they started to play that game, and that's how we got our first feedback. So we were quite happy to manage to go to production and to start to have feedbacks within 3 weeks. It's quite cool. At this point, running the entire infrastructure stack costs $6 per month, which is totally fair. Just a fun fact, actually our neighbor heard about it, and so he was playing actually in the office just next to us. So it was like a nice bonus.
We also saw some people next to train station playing the game, so it was a very proud moment.
So now that we know that people actually likes to play to it, can we scale? We asked that question because we knew that these 3 weeks it was just some bits of coding, and maybe the team wasn't ready because it was only on the free time of each consultant. So we asked ourselves a few questions, and notably, are there any limitation in the infrastructure, does that need a whole rework to make it work at scale or not? It didn't seem so. Is it a good idea to scale now? Do we have some more free time, and is the team capable of doing it? Yeah, let's go. And then, what are the impact on the team? Because it was an MVP, we were coding a bit dirty. Now it seems that if you want actually to scale, you need to ensure that you have the good DevOps practices and quite a few other good practices, not only DevOps.
So as a very first step to implement a nice, good DevOps practice, we started with having a nice continuous integration, continuous deployment pipeline. Well, with Serverless Framework, it was pretty easy. So it's just the Serverless YAML file that we integrated with Circle CI. Well, we chose Circle CI for continuous integration. It could be anything, in fact. And under the hood, Serverless Framework would take care of deploying all of your code and provisioning all the infrastructure by creating CloudFormation template under the hood. So that was the backend. And for the front end, we had same Circle CI, which will package your code, deploy it on S3 bucket as a static S3 website, and invalidate the previous CloudFront distribution and create a new one. And next thing, which was trickier for us, was testing. Now, when this part is trickier because with serverless, there is someone else who is taking care of your infrastructure. So what if I want to test this new function that I just developed on my local before I deploy it on the cloud? Answer is a bit simple, where you can definitely create unit tests as much as you could do. In fact, you should do test-driven development, like the way you do it for any other architecture. You can use some serverless plugins out there. We used a serverless offline plugin, which can simulate all of your API gateways on your local, and you can pretty much run entire website locally. But because it's a simulation and not the actual environment, depending on the maturity of the tools that you use, you may end up having a situation where it works just on your machine and not on the cloud. And well, to fix that, you get into the build, test, deploy cycle on the cloud, which is not so nice. But it's most of the times it's fine. I mean, it's not so bad. Other thing which is trickier is integration testing. It's trickier because imagine that I have some Lambda function which internally it depends on DynamoDB service, which is an AWS service. So in order to solve this problem, again you get help of some plugins which will be able to simulate. For example, DynamoDB local helps you to simulate your DynamoDB on your local. But the thing is, there are not many tools available for all kind of AWS services. And in fact, for us, at the moment, integration testing, we do have it, but it's very painful to set up locally, make everything work together with each other. And we have this not integrated with our CI, which is not so nice. It's something that we would love to have once the tools are matured.
So speaking about tests, you need to have also some environment to try your stuff, or dev environment. So yes, I'm serious. So one of the things that I discovered when I'm using the serverless, and especially like AWS platform, actually everything you create is production. It's deployed there. So the only way to actually separate production from development is actually a naming convention. And it might be trickier than it sounds to have like the right one and everything. So what we actually want on a test environment, because it's supposed to be exactly the same environment, like they are produced exactly with the same CloudFormation template, we just want to have the ability to test on test data on a different data set than the production one. So yeah, one of the examples of the challenge that we faced was to use like a custom domain name instead of the usually generated one, especially for the dev environment. But that's it. It's not more harder or trickier than that.
Yeah.
After that, let me show you a bit like the methodology that we used. So we were using Lean Kanban. So this vision, it was actually where we expressed that idea about like creating a geolocation game. And then it's pretty usual. So we had those workshops of story map, roadmap to establish like some kind of the vision. And then you have your backlog. And every time you actually deployed or have a user testing session, you kind of iterate on those three to make them like actually looking like what you're going to work next. Just a few key elements on what we did, and that was cool. So we did user testing at all stages. So every consultant that ever worked in our company was used as a guinea pig to play these games.
And their family members too.
And their family members too sometimes. It was kind of a developer-driven decision making, because all the people that were actually working on the tool, even the PO, were actually developers. So you can see in the tool that most of it was actually validated by developers. One real cool thing, and it's because of the cloud, so we have different subsidiaries all over the world, and we actually tested also with them our products. And to do that, we actually we wanted to learn as well. So we tried to deploy exactly our stack into different regions on AWS. So we had one stack in Ireland, one stack in Spain, maybe also Germany. And the last thing is, yeah, we use Trello as a board to be able to track everything that we were actually doing.
And so after a while, the product became even more popular, and we still were able to go seamlessly with serverless. We went ahead and create even more and more functionalities. And this is how it looked like in our project to work on serverless. So we used to have full stack team. So you pick up something from Trello board, a feature to work on. So you start working on backend, you add a Lambda handler definition to a serverless YAML file, implement it, do TDD, run Lambda locally using the serverless offline plugin. Then you go ahead with the front end, implement the API endpoint, do some testing if required, build and run it on local host, then test everything end to end on your local. If everything works well, merge it to dev. Dev was, it was a Bitbucket integrated with a Circle CI, which will take care of provisioning and deploying all of your Lambda as a dev environment on AWS. And on the front-end side, same stuff. It will make sure to deploy your front-end application on S3, make it available globally. And once you are happy with all that, and if you want to release it on prod, then you merge it to master, and it will take care similarly to deploy everything on the prod environment. And as a result, we had an autonomous team. And for example, over 6 months of time, we had 25 people working on this period, not all of them at the same time. And even with that, everyone was able to work on their feature autonomously without being dependent or waiting for someone to do something. And it was very fast to onboard a new team member once you have automated quite a lot of things. So things were quite nice. Well, until one day we woke up with this error. It looks quite scary. Well, it means that on AWS, for the one CloudFront stack, the number of resources that were allowed was 200, and we had exceeded it. So we started looking into it. So good thing is, it doesn't really mean that we had created 200 AWS resources within our little application. Thank God we were not that crazy. But it was more about the way Serverless Framework works. So for any AWS resource that you define within Serverless Framework, it will in fact create more than one resources on AWS. So it will create the Lambda function, a version, something about permission, API gateway, and so on. So, so there are few ways to overcome it. You can choose to have some nested stack and do some hack around it. But in fact, we thought that it was a good time to see what is going on. It was a good wake-up call. And we had a fresh look at our application, and we realized that the one serverless YAML file that we were so happy and proud about, in fact, it grow so big that it was very difficult to understand and follow through. And we were trying to develop serverless microservices, but in fact, what we created was a big, giant, distributed monolith. And so the solution was to split our CloudFront stack into multiple stacks. So the idea behind these 3 services is we tried to divide them into a kind of common functionalities that they were performing. And so it's basically 3 different CloudFront stack, and if you want to deploy something individually, you can do that, and so on.
Okay, back to the story. So now it's been 6 months that we're developing from now and then, and actually we get a client that is ready to pay to be able to use the product to create games for their user. So for us, that meant that we needed to change a bit the way we were creating games, because on the left you can see what we were doing before, and on the right what was actually needed. So we had to create this entire admin dashboard for anyone that is not, for someone that is not actually a developer or something, to be able to manage the lifecycle of all the games created and create the question, or basically handle all the games. So in terms of architecture, that meant that we actually created a new front end completely dedicated for the admin, and we added more lambdas and endpoints. Sometimes they are sharing the same data on the same DB, sometimes not, so it was like this, and we were still using CloudFormation and Serverless to deploy our stuff. With this came a new thing. We actually wanted to secure the backend, the backend admin, because for the backend on the other side, you didn't really need to secure it because it was just people playing, so it was okay. But now that people are paying for it, so we need to actually add more security. So we choose just to use API keys for Lambda authentication provided by the API gateway from AWS. We know it wasn't optimal, but it was easy to set up. It was good enough for our use case because we just wanted not to be like wide open, like just having a few stuff. And then we realized that that's when we were not cloud agnostic anymore. Which means that we were relying on specific features on specific AWS products to actually develop our games. So we were actually more coupled with AWS, and we couldn't switch like seamlessly. Another problem that we found at this time, it was a request from our new clients, was how do I do notification in app with serverless, because we can't obviously let like a WebSocket open. So I know this morning we spoke about the solution on Azure, but for us we were on AWS, and basically we found AppSync. So AppSync is another product from AWS that will actually handle the connection for you and expose an API, and so you just have for your Lambda to actually call the API and send the message that you want. And AppSync will actually handle the pushing the notification back to the device. So after this, we asked ourselves if it wasn't a bit too much to add all of these products just because we wanted to stay serverless. So we were like, should we go back to use a real server? And the answer was no. This was only one product. The rest was working fine. It was OK. And then we said, so is it possible to move to a different cloud provider if we had to? And the answer was also no, because at this point, we were using 8 different products from AWS. And that made us like quite impossibly, like not seamlessly. We could still do it, but it would take some time and rework to actually make it work. But
well, we still love serverless. In fact, we use Lambdas a lot within our organization. We have a whole infrastructure automation project which takes care of the different things on AWS, like auto-stop, auto-start, EC2 instances, or take care of billings and some billing alerts on Slack, integration to Trello to send some kind of smart notification, some reminders, and in fact, on the same line, we have created another product which is also serverless. It is in the MVP phase as of now, which is an automation to upload all the photos from your Slack channel to Google Drive.
Now, a few key takeaways. So as a developer, when should I go with serverless architecture? So on the bright side, at least for us, it was cheap and easy to bootstrap, so perfect for an MVP. Because of that, the time to market is quite unbeatable. We didn't see any problem to scale from no user to a few hundred. It was really easy to develop incrementally, like to develop new version and everything. Everything was a really good setup. And one of the good things is like every day it's evolving a bit towards a more mature ecosystem. Like right now, the Lambda product, for example, is really mature. And every day there are new features about new language or new stuff that you can do. On the less good side, we discovered that it has its own learning curve. So like if you just want to go on and use serverless, you might encounter quite a few problems. It's not like just a fairy tale. It can become very messy, like this huge serverless YAML file. So actually the team needs to have some strong DevOps practices. It couples you tightly with the cloud provider as soon as you want more capability than the basic one. I'm saying this because we actually choose also the platform. Like I know it's not always the case in every company, but we choose AWS because it was fitting our needs. And now tomorrow, if we have another project, maybe with more data, maybe we will choose GCP because it has other possibilities. And even though it's becoming more mature, not all tools are actually mature. It was a pleasure to actually develop with such framework. That's it.
Very good. Thank you.